In this video, I want to have a look at definite and indefinite quadratics. So a quadratic is definite if it has no zeros, so it doesn't cross the x or touch the x-axis. It's positive definite if it's always positive, so if that entire parabola is above the x-axis. And it's negative definite if it's always negative, so that means the whole parabola is below the x-axis. If it has one or more zeros or x-intercepts, then we say the quadratic is indefinite. So I want to have a look at the quadratic function, so just the general quadratic, ax squared plus bx plus c. Now there's 6 things that can happen here. If first we can have a look at when that a term is positive, so that means that our parabola is concave up. Then there's 3 things that can happen. We can either have our discriminant being less than 0, which means that we have no zeros, and we end up with a parabola that looks like this. If we get something that looks like this, that's what we call positive definite. So this is the condition for a quadratic to be positive definite. If we have our discriminant equal to 0, then that means it touches the x-axis at its vertex. It touches just there. And if we have our discriminant greater than 0, that means we're going to have 2 distinct roots. So these are both indefinite quadratics. Now let's have a look at the other case. Now the other 3 cases, if our coefficient of our x squared term is negative, so that a is less than 0, we have 3 cases that are very similar. So if we have the discriminant less than 0, again it means it has no zeros, no roots. So this is what we would call negative definite, because it's always negative, it doesn't have any x-intercepts. So these are the conditions for a quadratic to be negative definite. Now if our discriminant is equal to 0, we have 1 x-intercept. If it's greater than 0, we have 2 distinct x-intercepts. So both of those are indefinite quadratics. So what that means is, if, just summarising that, if a is greater than 0, so it's concave up, and our discriminant is less than 0, then we've got a positive definite quadratic. If a is less than 0 and the discriminant is still less than 0, then we have a negative definite quadratic. So our first example asks for what values of p is the quadratic 2x squared minus 4x plus p equals 0, positive definite. So again, for positive definite, we need a greater than 0 and our discriminant is less than 0. So in this one, our a is equal to 2. It's the coefficient of x squared, which is greater than 0. So that's all good. That condition is satisfied already without us doing anything. But what we do need is that discriminant to be negative. So our discriminant in this case is, remember, it's b squared minus 4ac. So it's going to be minus 4 squared minus 4 times 2 times p. So if we simplify that, we'd have 16 minus 8p. So we need that expression to be less than 0. So we're going to have 16 minus 8p is less than 0. We'll subtract 16 from both sides, and we'll end up with minus 8p is less than minus 16. And then we're going to divide by minus 8. Now don't forget, when you divide by negative, it reverses the inequality sign. So we're going to end up with p is greater than 2. So any values of p greater than 2 is going to mean that this quadratic is positive definite. Our second example asks us to find the values of k for which kx squared plus 3kx plus 9 equals 0 is positive definite. So we're looking for those same conditions, that our a is greater than 0 and our discriminant is less than 0. So in this one, our coefficient of x squared, that a is k. So we need to make sure that in our final answer, k is greater than 0. So that's something we've got to keep in mind when we get to our final answer and check that that's satisfied as well. But let's have a look at this second one, the discriminant. So our discriminant is going to be our b squared minus 4ac, which is 3k all squared, because that's the coefficient of x, minus 4 times k times 9. So 3k squared is going to be 9 k squared if we expand it out, so each of those things squared. And 4 9s are 36, so we're going to have minus 36k. Now we're going to have a quadratic inequality. We're going to have 9k squared minus 36k. We want that to be less than 0. If we factorise this, we can have 9k out the front, outside of k minus 4 is less than 0. Which means if we look at this left-hand side of that, if we were to graph that, we would have intercepts, x-intercepts at 0 and at 4. Now looking at that, that would be a concave up parabola. So it looks something like that. So just a really rough sketch. If we look at our inequality now, we want that quadratic to be less than 0, and that's going to happen in this region here. So that's going to happen between 0 and 4. So we're going to have k is greater than 0 and less than 4. So that's solving just this part for the discriminant. We then need to double check that it satisfies what we needed for the coefficient of x squared as well, which was that k is greater than 0. And we do have that, so that's fine. So values of k for which that is positive definite is k is between 0 and 4. In our last example, we're asked to find the values of g for which gx squared minus 2x plus 3g equals 0 is negative definite. So this time we're looking for that coefficient of x squared to be negative, so less than 0, and the discriminant to be less than 0 as well. So that means in this one we need g to be less than 0, and that's the condition that we're going to have to come back and double check at the end of our solving, at the end of our working out. So we need our discriminant then. So our discriminant is going to be that minus 2 squared minus 4 times g times 3g. So simplifying that, we'd have 4 minus 12g squared. Now we need that to be less than 0, so we're going to write our inequality as 4 minus 12g squared is less than 0. Now to solve that, we want to draw up a quick sketch of our quadratic. So just off to the side somewhere, we're going to pretend that's an equal sign and go through and solve it. So if we had 4 minus 12g squared equals 0, we'd subtract 4 from both sides. Then we'd divide by minus 12, then we'd get a third. And then we'd square root both sides, so we'd have plus and minus 1 over root 3. So that means that those are our two x-intercepts. So we'd have minus 1 over root 3, and we'd have plus 1 over root 3. Now those, because, by looking back at our equation, we've got minus 12g squared in there. So that means that our parabola would be concave down. So going up through this point and then coming back down again. Now if we look back at our inequality, we won't want that quadratic when that parabola is less than 0. So that would be this section over here or this one up here. So it looks like we're going to have two solutions. It looks like we're going to have g is less than minus a third, and g is greater than, sorry, not a third, 1 on root 3, or g is greater than 1 on root 3. But what ours has told us is that we need g to be negative. So we can't have g being greater than a third because it doesn't satisfy that first condition that we needed. So our solution is that g will be less than minus 1 on root 3. So that's a few examples of figuring out problems that involve definite and indefinite quadratics.